everybody. So what is unit testing? It's usually a term that's often interchangeably used with such things as integration testing. Think of unit testing as testing a component. Dependencies with side effects will need to be replaced with components that return happy signals, and sometimes purposely you want sad signals. You can't use network, file system, or DB context because that'll kind of mess things up. So given a set of input, does your invocation reliably produce output as expected? If it's mission critical and expected to work every single time in a given scenario, unit test it. Quite frankly, you may not see a return on your investment. If you don't see the value, simply don't test it. Your time is very important. Only write tests that matter. I'm a pragmatist. You can spend your entire budget on unit testing if you don't set limits on yourself. Integration testing is just like unit testing, but we begin to allow dependencies like network, DB, and I/O interactions. So what makes things hard to test? Non-deterministic stuff, using datetime.now, trapping a dependency, and that way I can't swap it out, such as newing up a business object inside your class. Now you can new up things like value objects, POCOs, and DTOs, but things that depend on network, disk, database, etc. just ain't gonna work. Global state, singletons, and statics, those make it very difficult because you don't know what side effect is causing your problem. And if you don't use abstractions at all, it's almost impossible to test. For this example, we'll be using NUnit in Visual Studio with C#. Let's go to the code. So in order to do unit testing, I guess we're going to need some code. So the code that you see before you is code we've just inherited from our coworker. We're kind of unclear on what it does. He always talks about it in stand-up, but we're still kind of unsure. The boss isn't so sure about his code, and he wants us to be able to run unit tests to be able to prove that his code actually works. So the first thing you'll notice over here on the right hand side is we just have our simple console app, and there's really not much to it. So when we want to do unit testing, we want to create a new project, and I usually create a new class library for this. So we're going to call this project super cool app tests, and we need to pick class library, super cool app.tests. We hit OK. That'll add us a new project here. We can go ahead and kill off this file here. We won't need you. And then we're going to install a particular version of NUnit. I'm going to use 2.64 for this particular tutorial. However, you can pick 3 or 2. And one other thing you're going to need to install is the NUnit test runner for your particular unit. You're going to do that through the extensions menu. So let's go ahead and install here. Make sure you add it to just your test project. And that was easy. And if we come up here to the extensions and updates, you can see that the ones that I have installed, which are, let's see here, let's type in NUnit. I have NUnit 2 test adapter. Again, if you're using NUnit 3, make sure you use that adapter. If not, make sure you have NUnit 2 installed. And the first thing we need to do is create a test. And we're going to create a unit test. And if I create a class here, and I'm going to just call this, let's call it unit tests. Plural, and it's just a class. The first thing you want to add on a unit test is a attribute, and we're going to call this test fixture. This is just kind of a radar signal for the test runner that we'll use later to be able to discover tests. A test typically has the test attribute, and we're going to do public void. If it's not public, obviously reflection won't be able to see it based on their setup, so we're going to do public void. And a lot of times the naming of tests kind of goes something like this. We're going to test that our calculator performs calculation. And notice how we have like underscores and capitals and Pascal case. So that's typically how it works. And the first thing we're going to do is we're just going to say hello world and introduce ourselves to our tests. And we'll fix a typo while we're at it. And so what we'll do is we'll provide an assertion. So what you do, you want to do in a test is you want to assert something is true. So in this case, we want to say true is true, and that makes no sense whatsoever, but it'll give you an idea of what's going on here. So the next thing we need to do is run our test explorer, and we do that by going here, other windows. Actually, I take that back. We go up here to test windows, test explorer, and there we go. And if we hit run after we build, Our test should actually show up here on the left. And there we go. We have calculator performs calculation. And if we run that test hopefully shall give us a green check mark, and it does. And if we notice here, it takes two parameters. The one on the left is expected. The one on the right is our actual value. So if we change one of these to false and run one of these, congratulations, now you have a failing test and you now have to go fix it. So this test really doesn't do a whole lot for us. So let's write a more meaningful test. So usually what we do is we have a system under test. And a lot of times people will use a variable SUT, system under test. And we're going to test our amazing, not Amazon, our amazing thing. But the problem is we haven't referenced our other project yet. So let's go ahead and do that. So if we go in here, we need to reference our super cool app. And now we can reference our amazing calculations. So that's the system that's under test. Next thing we'll want to do is we'll want to, I don't know, test the calculate value method here. And it looks like this takes an email address to and from. And we're going to go foo@bar.com. And we're going to do bar@foo.com. And that returns a value. So yes, let's take that value. And finally, we're going to run one of those assertions. So is it equal? So is what equal? So we're going to expect a number, apparently, from here. So it could be the number 10 for all we know. And is it equal to 10? I have no idea. So we're going to go look at code here in a second. But let's just run this real quick. And we will determine that this is probably not going to work. I'll be really surprised if I guessed it right. And sure enough, our test is failing here. So what we'll want to do is we'll want to go into the calculate value method of the amazing calculations and go, okay, looks like we're taking a 2 from the calculated values. Looks like we simply take the length of one plus the length of the other. We do some date stuff. Looks like we're going to set an email and we return that value. So I guess if we go back to our test here and we count the letters, there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So this should be 22. Let's try that and we run that. Hopefully we now have a passing test. And what I didn't show you before, which I will this time around, is you have this pane down here that gives you a little more information on what happens. Basically, it's saying, wait a second, it's not even worried about whether or not the value is correct because it's blowing up way beforehand. It's saying something about an email address and I can't find some SMTP server. Well, crap. What I could do is I could add an app config here and configure my SMTP, but in that case, we would have an integration test. A unit test means I have no dependencies on networks, on databases, on system I/O. So what we're going to have to do is scratch our head a little bit and go, well, wait a second. I'm trying to actually perform a calculation and get this calculation right. I really don't care if the email goes out. That's secondary. That's a notification. So how is it that I'm going to have to, or how will I be able to just say skip the email? Well, we kind of got to look at this class. And first of all, we're going to rename a few things because, again, I can't spell. And then secondly, what we'll do is we'll kind of scratch our head and go, okay, well, here's problem number 1. We've got a trap dependency. So it looks like we depend on email system 2000. And if we look at email system 2000, sure enough, we have system.net in here and we try to send an email. Wouldn't it be nice if I could just say, you know what, skip this part? And we could. The naive way is to come into amazing calculations here and comment this out. But if we commit that, send that to source control, obviously we're breaking this. That's not a valid thing. So what we need to do is swap this out. And this is a solid principle here. So the first thing I want to do is I have to address this email system 2000. And I will do so by looking here and go, you know what, you've got one method. You take this as your signature, and that's it. So let's create a quick abstraction, which this is a good example of why you should always be using abstractions. So I want to do an iEmail notification. And it has that as its signature. And now I can come back here and say, okay, you conform to the iEmail notification specification. And now when I come here, I still haven't got rid of that dependency. So what I'm going to do is dependency inject, and I won't use a framework or anything. I'll just simply use a constructor here, and I'll say, you know what? I need an email notification, and rather than this getting newed up here, we are going to just put this there, but we'll use dependency injection principles by setting a private variable here. There we go. So of course this won't compile, because if we come back out here, it's saying now I need an email system. So we can do email system 2000. So far so good. If we come back here, build, and run our test, what should we get? And looks like we have a build error. So before we get that far, yes. So our system under test, in fact, our test isn't compiling. So we have to do the same thing here. We got to do new email system 2000. All right, now maybe we'll build this time. Yes, we do. And now let's run. All right, looks like the test ran and same problem. Wait a second. All right, it's because we're depending still on that concrete implementation. So wouldn't it be nice if I had the ability to swap that guy out with something that just said, yeah, sure, I sent the email. And to do that, we'll come in here into our testing framework here, or our test project, guess not framework. We're going to add fake email system. And we're going to have that conform to the email notification interface. There you go. And rather than just throw an exception, we're just going to have it do nothing. And now when I come back to my unit test and I actually swap out here, we want a fake email system. And now let's build this and rerun our test. No whammies, no whammies. Hey, I have a green check mark. So essentially, we've calculated that, yes, given a amazing calculations object, I can fake out the email with another email system that basically does nothing, just for test purposes. And then I can perform the calculation and make sure it's true. So there's a few things we can take this a little further. So rather than just have a hard-coded one test case here, let's test a few cases here. And so we can do that by changing this to test case, changing the format there. Now we can take parameters here. So maybe we take string to, string from, and expected. Let's go int expected value. All right, so we know that if I pass in foo at bar as the to, and then bar at foo.com as the from, that should be 22. So now that we have those parameterized, I can say to, now I can say from, and this would be our expected value. All right, so far this really shouldn't change anything other than we moved from hard-coded out to an attribute-based. And let's see here, one test passed. Let's see, it seems like it didn't run properly. And it did. Okay, what we can do is we can say, you know what, that was great, but let's run a few more test cases just to be sure. So foo at foo.com. See, we got rid of 1, 2, 3, 4 characters, 18, and for now, let's just do the 2. And now I can come over here and I can run the tests, and now I should actually get 2 particular ones. And you know, let me run this one here. It's because I didn't build, that's why I didn't show up that last time. So essentially, they both work. So we've got 2 tests, and they run. Each one of these attributes are now their own test. So, great. That works. But you know what? We just now noticed that foo.com is not a valid email address. And, how do we prove that later on when it does a check to say that the email is valid, that it actually works? Well, we can write another unit test. And so what we do is we come here and we can say test, and we're going to use test case this time. Public void is email valid. And we're going to take, caps lock is killing me. We're going to take an email here and we're going to say, is the expected value good or bad? And there we go. So if we do foo at bar.com, and I think that's valid. Yep, and we'll do a true. And now I know at foo.com that should be invalid. So I have in our email extensions here a little extension here. It says, is the email valid? And this is used in a few spots, and in fact it's in the production concrete email system 2000 as a input there. But since I'm swapping that out, I'm not actually going to hit this code just yet. So how do I test that whether or not this is actually going to find those email addresses valid or not? And that's what we're doing. So if we go back to our unit test here, we're going to do var system under test equals, well, you know what? We don't have to do that. We can just do value equals email dot is valid email. That's my unit, or sorry, extension method. Now we can assert is our equal. How about we go with that? So we can do value. Oh, actually, we're going to do expected value and value. So on the first pass, it'll pass in foo at bar, and it should be true. And if it passes in foo.com, we should get false there. So let's run this real quick after we build first, so the test runner sees everything here. And side note, you can use ReSharper to run unit tests as well, and I'll show you that before we're done. But this is just the free NUnit runner. And so if we expand this pane just a little bit here, you'll see that foo.com is there. So let's run both of these, and foo@bar.com. And these should both pass, and they do. And if we were to say this is true, hopefully one of our tests will catch that and say, you know what, that's not true. Foo.com is not a valid email address. And sure enough, down here, this is what the ReSharper one looks like. And if we rerun the test here, oops, let me hit run all. Let me try that. There's where it's telling you, nope, I'm sorry, foo.com is not a valid email address. So you know for sure that your unit tests are working. Now, in general, this is most of what you need to do unit testing. What you don't have here is some additional things that you can do. A setup method, where it's just basically a run it once per test. You can do a teardown, a setup. You can do all kinds of things. So there's a bunch of things in the manual that we're not going to cover here today, but is definitely doable. The next thing you can do is, instead of having an actual concrete fake system here called, those are also called stubs and mocks, you can use a mocking framework. My favorite one is MOQ. And that's a little bit more exotic, and we won't cover that again today, but that's what MOQ will do for you, also known as mock. And in general, what have we done so far? So if we come back out here to the actual program here, we are now actually running new amazing calculations, and we're testing this object and this object alone. We are doing zero testing on this guy here. In order to actually do a unit test on this one, we would have to do an integration test. So let's go ahead and add an integration test. And you can name your classes as fancy as you want. We're just going to call these pretty basic stuff here. And again, we're going to need test fixture as an attribute here, so the runners know where the tests are. For this one, we'll just do test. We'll do public void does email system (2000) work. And that's obviously going to be a tough one. So if we call it the system under test equals new email system 2000, there we go. So what are we actually testing? We're testing this class right here, and it has one method. And we're going to do a send message test here. So we're going to do system under test that send message. And for now, we're going to send it a bad email address on both of these, but either one is fine. And we should actually expect that an exception is thrown. So foo r, okay. So when we run this, let's see. We'll just run it. We'll see what happens here. And here's what it looks like in ReSharper. And again, I'll run it for everyone here in over here. Email system does not work. System says an exception. An email supplied is not valid. And if we were to trace that back to the appropriate line, we know that it's going to be right here because our extension method has already been tested and told us that yes, that won't work. And what we can do to get that test to pass is we can go back to the test and we can say, you know what, we accept or expect an exception to be thrown. So we can do assert throws, and we're going to just do exception, and we're going to need to use a lambda expression here. Once we get that imported properly, we're going to say, you know what, run some code. And we expect that bit of code right there to run or to throw an exception. So there you go. Now if we rerun this test, hopefully it passes, and it does. So what happens though if it doesn't throw an exception? So if we come in here and put in something that doesn't throw, your test will now fail. So everything worked great. That's the problem. And you can see it down here in ReSharper, and up here you can see it in the test runner. So in general, this is going to get you going. I don't want to take too much of your time today. We can cover advanced topics here in another video at another time. But right now, we are able to at least write some tests and move some dependencies around so that you aren't trapping things. We did so by moving the new email system into a constructor item here, and there's various ways to do that through dependency injection. Again, kind of not what we're covering today. The email system 2000 uses the isValid extension. We wrote a test for that, unit test. And then we also wrote a integration test, at least the beginnings of it, for the email system 2000. What you'll want to do to test the rest of the email system 2000 here is you want to configure an app config in your unit test project to actually have an SMTP, or maybe output it to a file. Then you want to check to make sure that that file got created with the email contents. So there's many ways to do that. So again, this is the beginnings of unit testing, and we will cover more at a later time. Thanks for watching.